Good morning, friends. Myself, Dr. M. Channaya. I extend a hearty welcome to my YouTube channel. And friends, in this video, we are going to work out a numerical problem on the design for impact strength. And the question for today's video reads like this. A weight of 2 kilonewton falls on the collar provided at the end of a vertical rod. There is a vertical rod of diameter d and its value is given to be 25 mm. This d is 25 mm and it has got a collar at the bottom. So this is the collar provided. And what happens onto this? There is a weight 2 kilonewton dropped onto this collar provided at the end of this rod, which is 2 meter long and 25 mm dia. And we have been asked to determine the height of fall. So from what height it has to be dropped onto this, that is H is asking us, so as to limit the maximum stress to 200. Friends, you know very well, this is the case of an axial load, axial tensile load. So if the load is released onto this collar, this undergoes an elongation, and if it is simply placed on this collar without being dropped, h is equal to 0, it undergoes a static deflection. But when it is dropped from a height h, the deflection it undergoes is far higher than that caused due to the static load. The deflection due to the static load is static deflection, and that due to the impact load is the deflection due to impact load, wherein the value of this deflection is higher than that due to the static load. Friends, it's a case of an axial load, and if you refer to the machine design data handbook, for a case in axial load, we have the formula for axial load, we have this formula sigma dash is equal to sigma into 1 plus square root of 1 plus 2h by y is a formula available in the machine design data handbook for the case of an axial load. So we will know each and every one of these terms here. Friends, this sigma dash means maximum stress due to impact. Maximum stress, that is tensile stress in this case, due to impact, and its value is given to be 200, limiting the maximum stress to 200 MPa, that is 200 MPa. So this is given to us, so we know this value. And friends, this sigma is the stress due to static load, So in the case of an axial load is 2 kilonewton, and area of cross section a circular rod is pi d square by 4, and I will simply call this as W by A, where W is this load which is 2 kilonewton, that is 2 into 10 to the power of 3 Newton, divided by area, which is a circular cross section, this is pi d square by 4. And friend, this works out to 8 into 10 to the power of 3 by pi d square. 4 I have taken to the numerator, and friends, you know the diameter, 8 into 10 to the power of 3 divided by pi into diameter of the rod given to be 25. Friends, this works out as a value, so you can calculate this. We will call it as the value of sigma. It's a known quantity, so we know this value. So we know this sigma dash, we know sigma. Then friends, we have this term h. H is the height of fall, or the height from which the load is to be dropped onto this collar. height of drop or height of fall, or the height to which the weight falls onto the collar. That is to be found out asked in the question. And this y is the deflection due to static load. So friends, we have got the formula y is equal to WL by AE. Friends, W is the load that is being dropped, that is 2000 Newton, and L is the length, that is 2 meter, 2 into 1000 mm, divided by area of cross section. This is 8 into 10 to the power of 3, 8 into 10 to the power of 3, divided by 5 into 625. We can simplify this. Multiplied by E is the modulus of velocity of the material of the rod, that is 200 GPa, that is converted to MPa will be 200 into 10 to the power of 3. Friends, this is the deflection, and it will have the units as the value is 0.0407, 0407 mm. This is the value of y. And friends, you know all these quantities excepting this h. Y we have calculated, y we know the value. If you substitute in the formula, you will get the value for the maximum stress. That is, therefore, if you substitute in the formula, you will get this as, so just remove this. So friends, I am going to substitute these values. Sigma dash is 200. That is equal to sigma dash is the value I told you here. That is 8 into 10 to the power of 3 divided by 5 into 625. That is 25 square. Multiplied by 1 plus square root of 1 plus 2h divided by y. Y value is 0.0407. 0407. Friends, in this equation, everything is known excepting h. So we can find out what is h. H is equal to 47.087 millimeter. That is, this is the height from which the load has to be dropped onto the collar so as to produce a deflection. So this is the height of the fall, and is also being asked to find out what is the elongation due to impact. Friends, if we refer to the machine design data handbook, similar to this equation, we have an equation for the maximum deflection, that is the deflection due to impact, which will be far higher, far more than this value of y. So we have in the handbook y maximum or y dash, maximum deflection due to impact, is equal to 1, that is y multiplied by 1 plus square root of 2h by y. So this is available in the machine design handbook, DHP design handbook. We have this formula. Friends, maximum deflection y dash is equal to y. We have got the value is 0.0407, 0407 multiplied by 1 plus square root of 2h by y. 2 into h is 47.087 by that y. Y value is 0.0407. So friends, if you simplify this, you will get the value y max as 1.998 millimeter. So this is the value. So this is the deflection due to static load. This is the deflection due to the impact load. And you can see that the value of this y max is quite higher compared to that of the deflection due to the static load. And friends, in the same question, you may be asked to find out even the value of impact factor. So you may be asked to find out what is impact factor. So third part say, so impact factor is the ratio of maximum stress sigma dash to sigma. So friends, this sigma dash is given to be 200 MPa in the question itself, and the sigma is W by A. So this is 200 divided by W by A. W is 2000 Newton divided by area, or I will take A to the numerator. This will be pi by 4 into diameter square. So this is pi by 4 into d square. 200 gets cancelled, so 1 by 10 multiplied by pi by 4 multiplied by 625. Friends, if you simplify this, you will get this ratio, that is the impact factor. So impact factor represents to what extent the stress due to impact is more than that due to the static load. If you simplify this, you will get the answer. Very obviously, it has to be more than one in every case and in all types of impact loading. Friends, I hope the presentation was interesting. Go through the complete video without fail. And in case you have not subscribed to my channel till now, please do it today without fail. And share the information about my channel and my videos to all your friends. Thank you for watching my YouTube video. Have a blessed day.